All right, so we are in week 10, day one, continuing on with SQL databases. And this week we're going to focus a lot more on how to create the schema of our database. So what does that mean to y'all when I say create the schema? What am I talking about?
The layout.
The layout. Yep. Give me some more detail. The layout of what, like what? Want to use some keywords here.
The different columns and rows, I guess.
Yeah. So like the different tables and then the columns, those are the different fields in the database that we're going to be relating to one another and how all these tables and fields relate and how they work together. So that often is the most difficult part of setting up your database is trying to figure out how to basically not have just one big Excel spreadsheet with everything filled in the row. That's not what we're doing with databases. We use databases because we can what's called normalize them. We can break them down from a very large data set to like lots of small data sets that all relate to each other. It makes looking up so much faster and it reduces redundancy in our databases. So we're not like so we don't keep saying the same thing over and over in many different rows. We could just grab it from another table. So we're going to look at designing today a restaurant database schema. So in the README, it says we're going to use this restaurant database um, repo. First, I'm not going to click around in it because it actually shows you everything. I don't want to do that. We're going to sit here and brainstorm on our own the schema for our restaurant. So there's a few key things here for our restaurant. We're basically looking we're going to have customers come in and can order meals or let's say dishes. Uh, and can come in and order dishes and like, okay, and then our price setup's going to be weird. So this is going to make it a little different. We'll look at kind of, oh, that's not how you comment out in SQL. How do I comment in SQL? There we go, two dashes. Um, we're going to have we're going to say weird price system where main courses are like $10. Appetizers are 3, drinks, 1. Back in the day. Um, Certainly not anymore. They're like 3.50 now. Okay. So, first things first, I want to try to figure out what kind of tables and or entities is the term they use in SQL we will need in this database. So entities are going to be like if we're thinking about our object-oriented programming, it's going to be like the main class. And then you fit everything else underneath it. And those would be the columns. So looking at this, let's try to figure out what our main entities and or tables, if you'd rather think of it that way, would be in this database. So I'm going to need a way that I can have customers come in and order dishes, and then I have some prices. So what's one of the most obvious tables we'll probably need here?
A customer table.
Yep, customer table. And underneath the customer table, we'll probably have something like their name, and then we'll just put in an email, and we'll stop there. I could throw in addresses. Actually, let's throw in addresses, and we'll think about if we want to keep that there later. Okay, so we'll have a customer table. That's a good customer entity. Um, what else do we need to store information for our restaurant?
Like a menu.
A menu? Okay. So we can, I like the idea of the menu. I think that's a little more complex than I want to go right here. So I'm going to drop it down a level and just say like the dish. Right now I'm going to focus more so on, but menu, absolutely. I would probably have a menu and then I'd have a relationship to the dishes on the menu. And you can change that out for like a summer menu, fall menu, that sort of thing. Sure. But we're going to start easy and simple here. So I'm going to do the dish, and the dish will also have a name like hamburger. Okay. And I'm envisioning that I want to be able to keep track of the customers' orders, like what dishes they ordered, and the prices of those orders as well. So that's kind of what we're getting at here. Uh, keep track of customer orders, dishes are on their order, prices, and I guess price or total price. We're not going to do total price, just prices, the order. A little more detail there. We may or may not get into a lot of that. Okay, so for the dish, do we want to just keep name? And do we think we want to add anything else, or we want to leave it here, and why or why not? What are we thinking?
You need an ID.
Yep, okay. Well, all these, we're going to assume all these are going to have their own ID
Okay.
underneath them. Sure. Because
What?
every needs a unique, special primary key that is not duplicated, right? That's what
Yeah.
makes.
Uh,
So
are we category ID maybe as well? If do we have categories that we're putting them under?
category,
I see you got appetizers, drinks, and main course up there.
yep. This is for a weird price system. So yeah, let's do a category. Sure. We'll make this a little more complex than our README is doing now, but that makes sense. We'll go ahead and do that. Okay, so price. Typically, if I think about in a restaurant, I'm ordering something off the menu, I look at a hamburger, it's going to have its own price associated with it, right?
Mm-hmm.
And then a cheeseburger would have its own price associated with it. So in that scenario, I would likely put price here
Yeah.
if each one was unique. However, we have a weird system where all main courses are going to be $10, whether it's a hamburger, cheeseburger, steak, whatever. It's going to be $10. So
That's
if
really
I,
not an effective way to do business. Just not sure if you're aware of this.
yeah, we'll see. I'm just building this out for now, concept. We'll see how I
You'll
do in
be
the
out of
first
business in
year.
a week's time.
But this is a good example to think about when I said normalizing our database. This is where we start looking at redundancy here. If I put price under the dish and every single main item I plug in there is going to be $10, this field's value will be $10 repeated over and over and over and over again. So yeah, I could definitely keep it there and just keep putting in $10 for every main dish I put in here, but we're not going to do that. We're going to make an association later, but we're going to have a price table here because we only have 3 prices and they're going to be repeated over and over. So normalizing means taking it out of like a larger structure if it's repeated or redundant, and making it its own individual entity here. So under price, we will have, and again, this is no syntax, this is just me note taking. There is no syntax, rhyme, or reason here on what I'm throwing up in VS Code. We'll look at some tools in a second you can use, which Guillermo may have done over the weekend, potentially. maybe not. Under price, we'll just have value, the value of it. So like $10, $3, whatever. Okay. Anything else? What other table could we need? We have the customer, we have the dishes, we have the prices of those dishes. But I'm looking for, I want to keep track of the orders too.
Yeah, order table.
Order table, yes. Now, I would just put in order, but the README will tell you too, there are keywords in SQL, just like there are keywords in Python that you can't use without the potential of some conflicts arising later on.
Mhm.
Order is one of those. So we cannot use order. We're going to call it a restaurant order instead. Now, this restaurant order, let's just start. Okay, we're going to start with a minimal solution. We're going to build up to this, the relationships between everything. And we're just going to have like a when placed, when they place, just a timestamp of when they place their order. So we'll have a customer, dish, price, and an order. I think that covers it. We could get fancy, start adding all that other stuff. Like we said, menu. We could even have like the restaurant name. We can have vendors. We can have all sorts of stuff we start relating all around, but just start with the most simple setup. So now we need to start thinking about our relationships between these tables. And here is where some online tools can help you try to visualize these relationships if you can't just sit here and stare at the screen and try to draw imaginary lines in your head. Tons of different things you could do. You could just use paint to, some simple tools, but you just Google like free database design tools. Like this is one of the first things that popped up. It gives you 10 free database design tools you can use. There's like, this one's a very popular one. Looks like diagrams.net. Whole bunch of different ones you can choose. Quick DB D or DBD. Interesting. Oh, diagram at the end. Got it. I went ahead and picked this one because the documentation was easier to understand for me than this one was. But when you click that link, you go into the database design tool, it'll give you a template on the side here, which I've erased most of it out because it's pretty much our lecture today. And I didn't want to start drawing the relationships. But the cool thing about this is we can make relationships between different things. We could drag and drop, or we can type it in over here, and we can see then how things are going to attach up to each other. So let's finish making our tables that we were doing. I was in the process of doing this. So we have customer name, email, and address. Oh, let's go back and revisit addresses. We talked a little bit about normalizing the database with the price because that was going to be repeated. Now addresses. Don't think I will repeat an address per se. I could if somebody moves. Well, actually, yeah. What if I have like my parents living with me and they come in and they share the same address? So that address will pop up more than once. But one of the bigger problems I was thinking is we can have a customer with, they could maybe have a few different addresses as well. There's a whole bunch of different ways you can do addresses here that I don't think we'd want attached to the customer explicitly. Like if we had it just in here like this, then that customer would have that address and that's it. But if I split it out in its own table, you can have an address and then you can have lots of different customers linking up to that address instead of just defining it to one person. Does that make sense?
Yes.
Yeah, so nothing wrong with keeping it in there for a very simple schema, but if you are growing and scaling upwards, having it attached to a customer like this is probably not going to do well in the long run. So I'm just going to take that out. If I wanted addresses, I would make a separate table for it, but I'm not going to even include it. I just wanted to start thinking about the schema. Okay, so we have customer name, email, dish, name. Go ahead and add the category as well. What are all these things next to it here in my little schema design? This PK, what is that?
Primary
Primary
key.
key.
Yep, exactly. So that's the unique identifier for every entry, row, whatever record is the official way you call it within the database. So that is going to get a new one each time. Once one is made, it can never be remade. So once you make an entry and the number 2 dish ID pops up, there will never be a number 2 ever again. Even if you delete it, it will just keep incrementing each time. Okay, so we have primary key, we have name, string. I don't want to, we're not going to do index right here. We're just going to keep it easy. String? I don't think that should be string. Varchar? Varchar, however you want to say it.
Yeah, bar chart.
Mhm.
Let's do that. That was part of the example, residual from the example they give you when you come in, and it shows you a lot of of course, there's documents here if you wanted to look at that. But so we have that and email. I'm going to leave it as email, even though I think this has it as a varchar. Sorry, I say a weird way. Okay, so dish, we have, let's see, name, and then we have category. Like if I don't put anything down after it, it defaults it to integer, but this is also be char. Okay. Price. What do we have? Value, but of course we have to have a price ID. So I think in the example, in the README, it just has ID underneath each table. I would not suggest doing that just because if you start making connections, relationships between these tables, and you're trying to link to an ID, it starts getting really confusing trying to figure out which ID is actually linked. You'll have to start remembering the aliases and all that. If you're doing that, go ahead and just name it specific to what entity it is under. Just makes it a little easier. Of course, your choice, you do what you want, just makes it a little easier to keep track of. Okay, so we have the price ID, and that's going to be the primary key. Okay, and then we also have a value. I guess it's just an integer in our example. We could get fancy, but we'll keep it as an integer. Okay. And then the last thing we have is the restaurant order. And I'm just following exactly how this was set up because I don't know if I need this. I'd probably do that. Probably is what makes it a table. I haven't read through the documents exactly. But then we'll have the rest order ID. It's also primary key integer. And here we have when placed, and we'll make that a timestamp. Okay, so here were our entities that we decided, our tables that we decided we were going to have. Let's start making these connections now of how these are related to one another and how they interact. So where do we start? Let's first think about a customer. What can a customer have or do with any of these other tables?
The restaurant order.
So
We
a
have to
customer,
connect that somehow.
yep, okay, so we we envision a customer can place a restaurant order, right?
Yeah.
So let's go ahead and get these two together. So we need to connect them. So we'll make another field here underneath this entity, and we are going to name this one customer ID because I want to tie this to the customer primary key. But now, why am I placing it under this table here, the restaurant order? If I put customer ID, okay, so if I have customer ID under restaurant order, what is that saying for this restaurant order table or for each restaurant order?
That's where
The-
you're. Oh, go ahead, Joe.
I don't know if this is going to be right, Cisco, so
It's
I'll
fine.
preface that, right? So wouldn't the customer ID be here? It's a foreign key. It's pulling from that table, from the customer table.
Mhm. Yep.
So yeah, I think that's my answer. I don't know. So that was
Okay.
it.
So, like in layman's terms, then yes, this is pulling from this customer table. But what this is saying is that each order only has one customer associated with it, right? So if you're a restaurant order, there's only one customer. There's not two or three. If you start putting two or three values in this like key relationship, you're doing it wrong. That's the wrong way to do it. This should only take one number here for this situation. Now, customer, we don't have it linking up under here. We're having it go over here because a customer can have lots of different restaurant orders, right? So each entry in this table is going to have a customer associated with it and when that order was placed. So a customer can come in and place an order at 8 in the morning for breakfast. And so then it would be 8 a.m., customer one. Then later in the day, they could come back in and do another order. So then in the table, we would have a noon, customer one put in there. So that is why we do it this way. And then we will be able to figure out what order they have backwards. We'll look at that later. But for now, we're just going to make this association here. Did that work? No. How do I cannot create a relationship? Customer order, rest order, customer ID. Hang on, I saved right here my little cheat sheet of how the documentation was. Okay, so
I
we
just
have
I just dragged it, Tiffany. If you take that from customer ID, if you take that away, that restaurant order portion of it, and take it back to where it was originally, yeah, yeah, and then I just dragged it from restaurant order, the customer ID to that, yeah, or the other
the
way
other
around,
way.
yeah.
Okay.
So from restaurant order to customer.
Okay, yeah, you're pointing at where you're getting it from. That's how that works. So this customer ID is it's going to be these customer IDs. And this shows the little line there means one, and the little fork there means it's a many, right? So this is a one-to-many relationship. There is one customer for many different orders. There is not many different customers for one order. Okay. Can get kind of tricky trying to talk yourself into these relationships. um, but querying will always help you see if that was the right way to relate something. But we'll look at that later too. Okay, so we've got our customer can make an order, right? Can make lots of orders. So that is one relationship. Now, how does the dish fit in to this? Somebody just tell me when a customer makes an order, what's happening with the dishes? What do we do?
Are we assigning the dishes to the order?
Yeah. So when a customer makes an order, you add dishes to the order, right? Now, is there only one dish in my order? Or can I have lots of different dishes in my order?
Lots.
Lots, yep. I can have lots of different dishes in my order. Now,
Depends on how hungry you are, you know?
well, if the steak's only $10, I am very hungry.
Yeah, good call.
So we can have lots of different dishes in that order. Now, on the flip side, okay, so we can have lots of dishes in an order. Can a dish have lots of different orders assigned to it? Why not? A cheeseburger can go on Sally's order and it can go on somebody else's order. And then Sally's order can have a cheeseburger and steak and other stuff, right? So this is where that it's like kind of weird trying to figure out that relationship between all this. This is going to be a many to many because that cheeseburger, once that cheeseburger is on Sally's order, it doesn't mean it can't go on anything else, right? It can still keep going in other people's orders. And then Sally's order, she can put the cheeseburger on there, but she can also grab other dishes too. It's not restricted to just one. So that's the many to many. I'm doing the triangle, like the three on there. The many to many relationship. Can't just go ahead and do a 1-for-1 here, right? Because I don't want to put an order on this dish because it will tie it to that order and that alone. I don't want to do that. And I don't want to place a dish in this order because then it's set to just that one. I want multiple dishes. So we need to make a new table to go between these two to just hold both their numbers together for us that we can reference and see for this order number, we have these dishes assigned to it. And you do multiple entries like that. So this, we're going to make a table called order dishes. And it's going to have, we're just going to call it ODID. I don't know. It's going to have its own primary key. Okay. Everything gets its own primary key. Just go ahead and keep doing that. And it's going to have an order ID and a dish ID. And it's just going to hold the place between these two to hold all the time, like all the different lines of orders and dishes, basically. So order ID is going to associate with this, right? The order ID is going to come from this primary key for order. No, or is it the other way around? Yep, it's the other way around. Nope, it's not. Why is it not working this time? Okay, let's see. I should be able to just drag it. Wonder if I have to go to the front. Invalid rest order does not exist. We're underneath it. Sometimes when it does this, it's because you declared the table after or before it was supposed to be.
Um,
Let's see if the dish does. It's just this tool. I don't know how to.
So you
Uh,
what do you so the dish, your order ID wants you want it to go to restaurant order and the restaurant order ID, right? So
yes,
yeah, there you go.
but it's
Let's see.
not. This tool isn't doing it for me. I
It's
don't
not
know why it's not.
connecting. Try it again. Try the other side of it right there, the left side, that left dot. And
That's what I did first. I don't know what it's doing.
uh restaurant order ID. Okay.
Wonder if I could do the other way here.
Take away the colon after. Is it that is that colon? I don't know. Because maybe not. All your other ones have it. But yeah, take away the colon in there. See if that does it. No?
No.
Darn.
Wonder. Let's move. No, this should be fine. We got rest order.
Did
You
you
take
have
away the colon after rest order on your left side and order dishes.
wait, where?
So like where it's typed out on.
Oh,
yeah, there you go.
oh my goodness. Thank you. Yep. Learning a new tool with y'all. Now it's got it
Yeah,
open.
I'm walking along with you as you go, so I'm trying to.
I like this tool. It's just learning its own syntax that you have to use
Yeah.
and doing. Okay, so here we go. Here's the many to many. Oh, that's not the right way. That's supposed to be the other way. That's not. I guess I got dragged that way. Okay, yeah. Okay. Now, the many part is this table here. So these are the columns, right? So each entry in this is going to basically be like 1, 5, 1, 10, 2, 7. Like that's what this table's holding, is just a whole bunch of primary keys from orders and primary keys from dishes and just kind of associating them with each other. So then you're able to query this to be like, hey, give me all the dishes on order 5, and it will find everything with an order 5 and give you all the, dishes that are linked up with that order number. And we already talked about why we didn't hook them straight up to each other, and then why we didn't place them underneath these tables, because we don't want to lock down either of these into only having either one dish or one order, and that's it. Nobody else can order it. I got the steak, you guys don't get it. No, we're not doing that. We're sharing the $10 steaks. So that is our many to many order. Now, last thing here, look at this price. What are we going to do with this price?
Nothing.
Nothing.
Yeah.
Assigned to the dish.
Yeah, I want to put it on the dish. We're not the dishes need some prices. They have a category, but they don't have a price yet. So we're gonna go ahead and link that up. Let's add another. So how is this relationship gonna work? Somebody try to talk it out loud. What kind of relationship is it gonna have? Is it one to one, one to many, many to many? And where do I need to add a field if needed? And how do they link up?
It's gonna link up to the dish. So I would say 1 to 1.
One to one. Okay. So if the price wasn't repeating and it was unique for that dish, then yeah, I'd say 1 to 1. But remember, all entrees can have the $10 price value.
So then do you have to add another table in between again?
Don't know if I have to add another table in between. So let's think about, okay, so this dish, will it have more than one price?
No.
No. The dish is going to have one price.
Mhm.
Now, this price of $10, is it going to be assigned to just one dish or is it going to be assigned to multiple dishes? Oh, you've
You-
got mail.
That was me. You gotta so you did so category you so if so category needs to be changed if you're trying to connect anything from dish to the price, you're gonna have to change something in category to an integer in order to attach it to the dish, correct?
Yeah, I mean, we could keep category, but we could also just throw on underneath,
Mhm.
but not prints, price ID,
Okay, yeah. Let's
integer.
add another.
So we've said that each dish is only going to have one price, right?
Mhm.
So if I didn't have another table with prices stored, it would look like this. And I could do
Right.
this. But because we have repeating prices that were going to be used on multiple different dishes, I'm going to go ahead. We had that new table. So now I'm going to make this just the ID. So this dish can have one price, but like a $10 price can have lots of different dishes assigned to it. So it's
Right.
going to be a one to many, right?
Mhm.
Or, well, one price on many different dishes. That's the way it goes. It's weird. Okay, so one price. Is this the way I drag it
Yeah,
to
you drag it like
many
that. Yeah.
different dishes? Nope, that was the wrong way. See, the one's on this side now.
Uh, this- that's right though. I mean, well, I try. Does it matter if you collect? Oh yes, select the
Oh,
left or right side. There you go.
oh, yeah. Okay, so now this price will have one in it. But this price can be hooked up to many different dishes. So with this schema, the little many thing is like, oh, let's see, how do I, now I'm confusing myself with how the schema looks. One rest order or one restaurant order. One customer has many different restaurant orders. So one dish.
Wouldn't it be the other way around? So it's
Yeah, yeah, yep, yep, you're right. Yep. So it was right the first time, not that way, the first time. There. So one price can be assigned to many different dishes. That's right. This is how this design works. The many fingers. One price to many different dishes. And then many different dishes all have only one price. Did I just really confuse y'all with that? Or are we following? The dish only has one price. The price could be on many different dishes. So the many goes over to the side that can have the many different. So the customer can have lots of different orders. So that's why the many is going over here. But the order only has one customer. And with our many to many relationship here, one order comes here, which can have lots of different order dishes, and then one dish is assigned to lots of different order dishes as well. That's that many to many. If this visual representation confused you, that's okay. You could do it whatever way you want to. But do we understand how we've got these one to many and how we even figured out this many to many here between the order and the dishes? If not, that's okay. We will practice with another example in a little later here. Okay, so now that we've got our schema and our relationships set up, it would be time to create our tables as we've laid out. And in order to save time, let's just look through the init in the repo that they gave you. So the initialization file, we've seen this a lot lately, right? Everything has been like a Docker image for you to run in our SQL databases. So all of our Docker files are pretty much the same. We use a Postgres base image, and then we have copy this init file into this entry point place, and it makes it just set up and run right away. Have we seen this setup file before? Or is this something new to this repo? New, okay. This is a script. Oh, do we have other comments on it?
Yeah, we see it.
Yeah, Guillermo showed it to us very briefly, like at the end.
Okay.
But I mean, it doesn't hurt to go over it again. I think it's cool.
Yeah. So this is just a script that helps make your life so much easier. And what the script includes is basically every command you'd have to run in the terminal to get this up and running. Instead of typing it out line by line in the terminal, we've thrown it all in a script that we could just run in a little boom, 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 boom. All right, good to go. So let's look at what the script actually does for us. So if we say Docker build the restaurant database, that's going to, what is the Docker build going to do?
Build the image.
Yep, what is it using to build the image?
The database that you a restaurant DB.
Okay, so yes, how it's doing that is this build, Docker build, is the keyword for Docker to say, look in your current directory and find a Docker file. So this first line is saying, build an image off this Docker file and name it restaurant database. Crap, I forgot the dot. I think that's everywhere in this or at this.
Yeah, that just places it in the in the source or root directory for the container or image, if I'm not mistaken.
I thought it was
It's
pull it from like where I'm currently located.
yeah, that's what it is. Yep. Now it's all coming back. It's been a few classes since we've done that. If your Docker file is not in your current directory, you have to do that here. This is saying, look in my current directory for the Docker file. So yeah, Docker build, if you don't specify a path, it's going to look where you're at. But if it's somewhere else, that's when you have to start adding, your directory name and where the file is located. So that's our first one. We did that in the terminal, but now we've thrown it in a script file. So it will auto run when we run the script. Next up, after it builds the image, it's going to run the image. It's going to name it the Postgres database. This RM is, of course, when you stop it, it will remove the image, clean it up. This is an environmental variable here. It's the Postgres password in order to access the database. And then -d running in the background. And then the name of the image you're running. Okay, so we build the image, we run the image. And again, this should be very familiar because we've typed it ourselves or copied and pasted it at least from previous lectures. And then we sleep 5. This is because remember when we would run our image, sometimes takes a minute for those images to spin up and show they're running. So we want to give it a minute to establish itself, start running, and be ready for us. And then we exec into that image, into the database that, now actually, when you exec into and then you do this PG, pSQL, it's going to put you in that Postgres SQL terminal that lets you interact with your database. So each of these were individual commands you had been doing, prompted by our repos. And instead of now typing each one out manually, you can just run this file. I have not run it yet. We will see if it works. Am I in the current? Yes. So you do that by just doing a, dot here. Let's go ahead and run it. Script. And look, it's doing what we wanted it to. It's building our image right now because it found that Docker file there. And now it's going to, well, it did everything in quick succession. You can hardly see. It ran the image, then it stopped for a minute, and then it execed into the image. So now I'm at that point where you can actually interact with the database here. Okay, so I am going to go back to the initialization command that we gave it. This is the implementation of, not this part, right? This is the beginning where you create the database and all that, but I'm looking at here, the tables. This is how we implement those tables and their relationships. So we had customer. Let's see if we can just, I'm going to half and half here so we can look at her. Okay, so customer didn't have any relationships down here itself. It just has its primary key, has its name and email. So we got those there. We have create table customer. We do ID, serial primary key. I don't want to name it ID. It's too late now. I ran the file though. It is named ID, but if you want to rename yours before you run it, this is where you would put how you want to rename those primary keys to be a little bit more unique instead of just ID. But we'll go ahead and stick with ID because I already ran this too late. All right, so next up we create our rest order. Tell me, do we think it matters in what order I create these?
No.
You don't think it matters what order I create these tables?
No.
Well, it does. It does matter what order you do them in. But you would run into that if you tried creating them however you wanted because of our relationships. So if you try creating, if I were to, let's see, what do we have a relationship with? Order dishes. If I were to try to make order dishes up here and associate it to an order ID, it's gonna, SQL goes down the line. So if there's no order ID created, table created up here or order, it's gonna be like there's no such thing. I can't find an order ID to relate to this field. So it does matter the order, but just make sure that if you're associating something, whatever you're associating it to is created first, and then you're good. Yes, Art.
The tables in your init file, you manually created those, correct?
These are included in the repo for
Oh,
today's README. If you pull it down, they are
okay.
already there.
Okay, so what I thought happened was that out of this nice little schema program we have here, I thought that you may have imported that file into the current file and it created all those tables for you. But
You definitely could do that. There is a feature, but why? Why is it missing? Customer is missing field type line 7. Field
Yeah.
type.
I tried to use that yesterday, Tiffany, and it doesn't convert well.
Okay. Yeah,
okay,
I would
so this is for visual purposes mainly.
pretty much. Yep. And if you want to
Okay,
just
okay.
draw on some notebook paper, that works as well.
No, this is pretty awesome. I like this. Thank you so much.
I can pull them all over here so I can see them as I'm relating. Okay, so going back, customer doesn't have any relationships here that we need to worry about because it's not getting anything, any primary key entered in over here. Other stuff is relying on it. So it just has its own stuff it cares about. That's it. Next up is restaurant order. Now this one has its primary key, when it was placed, timestamp, and the customer ID relationship. So we could see we create table rest order. We have our primary key here. This fancy timestamp with time zone default current timestamp. Sure, going to give you the timestamp here when placed. And then this is our foreign key area here. So customer ID is an integer field that references the customer table ID. And that is the syntax for SQL on how you do the foreign key relationship. And the foreign key is usually going to be the many portion here, the end of the many, whatever. So next up, it looks like they went to price. And why did we do price first?
Because dish references the price ID.
Exactly. Yep, perfect. So even though it's last in my list here, and I'd love to just go down the order and, put things in nice and neat, dish references price, so that has to go next. And that logically is the best thing to put next because this doesn't rely on anything besides itself, right? It doesn't have a foreign key in it. It just has its primary key and another field. So we create the table price here with their primary key and that value field. Next, we could do dish because the only thing it relies on is having a price ID situated. So again, we have our primary key, the name and type, and then we have price ID, which is an integer field that references the price ID. Again, we can see the price ID is the end of the little many to many or one-to-many relationship here, and it references the one part here, the one ID. Trying to paint pictures for people who might think differently than me. And then finally, after we've got all those established, we can finally put in order dishes because it's a weird one. Its only fields are reliant on other tables being created first. So we have an order ID and a dish ID, which are both integer references. They're foreign key references to the other table's IDs. So we see how the syntax lines up there. So this is our anything that just has one thing referencing another. That's our one-to-many relationships here. And then this that has both those references is our many-to-many relationship. Okay, so now we can start messing with it. So I got it up and running, and in that initialization thing here, we can see it's already seeded data into our database. So we can start querying this and taking a look at it, seeing what kind of information we can get. So first things first, let's go ahead and answer the question, how much has Randy spent at the restaurant? Okay, let's look at our schema again then. Good visual representation to try to figure out how we can solve this. We want to know how much has Randy spent at the restaurant. So what are we probably going to need? What's the first thing we need? We need Randy, right? We need to find Randy. He is a customer. So customer seems like the most important table here because we want to find out how much Randy has spent at this restaurant. So there are a few ways we could go about this. Per the README, we're going to do this other way first. We're going to query the customer table to figure out what Randy's ID is, what his unique primary key ID is. So to do that, let's go ahead and select, we'll go back to half and half. Let's select ID because we want to find Randy's ID, right? So we're going to select the ID from customer.
Where are you typing, Tiff? I don't see it yet.
Oh, is it not shown on the bottom of the screen there?
Is it, maybe it's cut off because I'm on one screen right now. Apologies.
Okay. Let me, how's that? Is that better?
Yeah, yeah, don't adjust to me though if it's just me, my bad.
No, it's fine. It's fine. It's kind of bunched down in the terminal here. I wish I could just clear and it would work here, but it doesn't with SQL. Okay, so we're selecting the ID from customer. We want to find the ID from customer. We want to find Randy's ID. So what's my where statement here? If I want to find Randy's ID,
Where name like Randy.
our name like Randy, sure. We could do a like, but I know for a fact he's in there as Randy, so I'm going to say just equals. Our name equals Randy. And with our semicolon. Okay, so 3. Randy is customer 3 in our database. So now, if we want to find out how much Randy, aka customer ID 3, has spent at this restaurant, what do we have to do first? Let's do the breaking down. So what's the first step? We need to identify all the tables we need, right? So I want to find out how much Randy has spent. It's the most obvious table I'm definitely going to need.
Customer.
We already found out Randy's customer is, he's ID number 3, but I want to find out how much he spent.
Okay.
Price.
Or,
Price.
go ahead.
Yes. I want price. I want to find out how much he spent. So I want like prices, right? Find all those prices he's spent at this. So we've already figured out his customer ID. So we can start linking together the tables to go from customer down to price with his ID, right? But yeah, you're right. We do need customer too. We could skip it, but let's start at the beginning. That's fine. Let's start at the beginning and go through from customer all the way to price. And we're going to link it all at the same time. Now, we usually start off with selecting everything from, okay, so let's start with customer. Let's see. Okay, we're going to start off with selecting everything and limit the first like one, we'll limit to 1 response, basically. So now we have to start joining, right, to get to price. So how do I join? Select all from customer C.
Rest order.
So rest order is next. Okay, join rest order. We'll call it O, I guess, rest order. RO. Join rest order on, how are they joined?
Customer or C customer ID to
This is confusing. In my table, it's just ID here. And
oh,
yeah, sorry.
all right,
So C.ID
to what's it? RO, and that's going to be ID as well.
Yeah, my schema
No,
picture
customer
is
ID.
leading us astray.
No, it should be customer ID.
Is it rest order in here has ID? Oh, customer ID. Yes, yes, you're right. Yep. Yeah, customer ID. Perfect. So this ID is the same as customer ID under rest order. Now we're going to join order dishes. And we're just gonna fly through this now. Wonder if it matters if those are capitalized. We're going to join order dishes on, it looks like we have rest order, and then ID is equal to order dishes, order ID, right? Then we go down and join dish. DE on. We have dish ID equals od.dish ID. Somebody yell at me if you see something wrong. Otherwise, we're just going to keep. And then we're going to join price P on ID equals dish price ID. Okay. Now, if I just select everything from customer C, let's limit it down a bit. Because we don't want everything, right? We already know at least one limitation here. We're looking for one specific person, right? We're not looking for everybody and everything. So we can already limit this down a little bit initially. So how can I limit this a little bit? Who has an idea? Don't cheat on the README. Oh, you're muted.
I didn't say anything.
Okay. Okay. So I don't want everybody, right? I want just Randy. I want to know all of Randy's stuff. So that's probably what we can limit down to, right? And we know Randy's customer ID is 3.
Mm.
So I could select everything from here and just look at it all. Or it can, right away say, you know what, get everything, but only give me when a customer ID is equal to 3. So that will give you all this stuff still, everything, but only if the customer is Randy. So we can say where the customer ID is equal to 3. Okay, this might blow up a lot. Let's limit. I don't know how much is in here still. Let's just take 5. Okay. RO, dang, I knew I would do this. I was flying off. Okay.
Yeah, all your IDs are, they all should be ID, I guess. So you got an order ID, customer ID, price ID,
Oh,
dish ID.
that one's customer ID. That's why that was wrong.
Did you change it?
It's a typo. Oh.
Yeah. No, I mean from your init SQL file, because I still see ID on them.
Yep, these are ID. So that's those ones. And then price ID, dish ID, order ID, those are the
okay.
foreign key areas, but I spelled customer wrong here.
Okay.
Okay. Oh, darn it. Oh, did that fix it? That looks right. Customer. Okay. There we go. Okay, so here in this query I just did, I said, give me everything where the ID equals 3, which we can see here is Randy's stuff. So this is what that returns. If I just select everything from joining those tables together, then it gives me all of this. But I want the total price that he has spent, or the total amount he spent at this restaurant. So if I want the total of something, what aggregate feature should I use in my query? Do
You
we
want to
remember?
sum that?
Yep, sum, exactly. So who here is really confused by sum and how that works? Or do we kind of, yep. Sum can be a little confusing. So think of sum. If I want to say, find the sum of that, the only logical thing is value here because the rest are IDs. But if I want to find the sum of value, if I do sum value, it's going to add every single value in this column together. So I wrote my query in a way that it only returns Randy's orders and everything. So if I sum the value, that's going to give me the total of all of his orders. But if I did not query just for Randy, if I just said, give me everything, but sum the value, then that adds every single return together in this column. So it could be Randy, it could be Sue, it could be Joe, Bob, Mary, like anybody who is ordered, it will add together all of the values in that column. So we limit it right now to kind of pinpoint what we want to add together. We don't want to add together the total spent at this restaurant. We just want to add together Randy's total at this restaurant. So let's, /Q. Okay, so let's look at our query and see how we can add that sum feature. So right now we selected everything from customer C and joined all everything together and limited it, but I want to return the total amount spent. So if I want the total amount spent, that has to be in my select statement. Anything you select will show up in your return, in your response. So let's just do that and we'll edit this. So I don't want to select everything. I want to just select the total amount Randy spent. So let's go ahead and change this right now. We want to select the sum of, now we want to select the sum of that column, which was, what's that column called?
Value. Where is it at?
Value,
Yeah,
yes.
value. Yeah, price
Yep.
value.
Price, and it's under the price table. So we need to, so I could just say value, and as long as it doesn't exist in any other table, it should find it, but don't rely on that. It's best to explicitly say which table it came from and then which field you're targeting. So this is going to come from price because we did all of our aliases here, and price is P. So the price value column. So now this query is saying, give me all of that value column added up together where the customer is Randy. Oh, I always do that. But I don't want to limit, right? If I limit 5, that's only going to give me 5 rows and only add up 5 values for the total amount spent. I want to give everything. So we want to return everything where Randy was the customer. And I want to add all of that dollar amount spent together, which gives me 84 bucks. Randy has bought several different things, and all those values in that price column or price table, the value column, have been added together to equal 84. Now, if anybody's following along in the README, I did not do a group by, which it does in the query in the README. It throws on at the very end to group by the customer name. And if you do a group by, you always have to put that in your select statement. So it returns as a value. So let's do the customer name. So this is what the README has. It has grab the customer name and the sum of that, all those dishes, where that customer is equal to 3, which is Randy, and group it up by the name. Pretty much looks exactly the same, except it throws his name on there. Now, tricky question here. Do I need this group by? What is this group by doing for me? Any thoughts? I'll take wrong thoughts as well. We'll kind of.
I have one thought.
Okay.
No shortage. Well, it's just simply a display. I mean, it's not changing the file or anything. And you already know who you're looking for, so it's not that important. You could do without it, but it's just displaying.
Well, it is displaying because I put it up here. Anything that you want displayed has to be in your select statement. So if I took it out of here, first off, the group by wouldn't work because it will tell you if you want to group by or aggregate like that, you need it in your select statement. But theoretically, if I removed this, it would still do some stuff. So this is more than just, this group by is more than just the display right here. The display part comes up here. So what does grouping do in general? When we group something together, we just put it in a group, right? So if I were to group by name, what do we think that's doing to the data in the database? It is essentially grouping the names together in their own little mini groups to go ahead and do this sum value on. If I didn't have a group by and I didn't have a where the customer ID was 3, it would add all the values for prices together. Doing this group by though, I actually don't need, let's see, oh, we don't need this ID here. What do we think this is going to give us?
It's just going to give you the sum of for Randy.
No, for all the customers.
Yep, all the customers. So group by is grouping together into smaller little groups for you to like do your little aggregations and whatever, figuring out sums of individually. So when I say give me the sum of this column, but group it together by name, it's taking all of Wally's orders and putting them and summing those orders. And then it's putting Steffi's orders together, and because we're grouping by every name that's in this database. And so then it can sum and add together their orders based on the name of the customer. In Randy's case, when we had that where customer ID equals 3, we did not have to do a group me because he was the only person that returned in our query. So we didn't have to group anything because he was the only data we got back. But if we removed that and we just queried the whole database, grouping by name allows us to break it down by each person's orders. Just a fun little side note there that I thought we should go into because group by can get confusing at times as well. But when in doubt, go ahead and just query your database and see what it gives you. All right, so that was today's lecture. Any questions over any part of this that we may need some more clarification on before I end the video?
Yeah, so the the SQL that we're using in this init.sql, that's just regular SQL. That's not Postgres, that's not I forget the names of all of them, but anyway, that's just regular SQL, correct? That's not.
Yep.
Yeah.
And
Okay.
that's how you interact with Postgres as well. It's just SQL statements. Same with
Yeah.
like SQLite, I think. I don't know. Microsoft's this, what is it? SS SQL, Microsoft SQL Server stuff, management, whatever. That's also just interacting with SQL
Mhm.
syntax. So yes, we're starting here, but eventually we will use another program to kind of be an in-between, a go-between between our backend and the database. And we're not going to be using straight up SQL. We're going to be using what our program uses to
Right.
talk to it. But this is the very basic foundation here of databases or SQL.
Okay.
Yep. Good question. All right. There's no other questions. Let me go ahead and stop.